Hey there, and welcome. Today, we are going to dive headfirst into the world of brain teasers. We're going to look at some classic puzzles that, yeah, they might seem a little tricky at first, but they're actually amazing exercises for learning how to think. So let's get right to it.
First things first, we got to get our mindset right. These puzzles, they are not tests. There's no grade at the end. Think of them more like a session at the gym, but for your brain. Every single puzzle you wrestle with strengthens your logic, your creativity, and your ability to see a problem from a totally new angle. And those are skills that are, well, useful pretty much everywhere in life.
So, here's our game plan. We're going to start by decoding some fun logic puzzles. Then, we'll see how a little bit of simple algebra can be a total secret weapon. After that, we'll go on a hunt for hidden patterns, and we'll wrap it all up by putting together your brand new problem-solving toolkit.
Okay, our first stop, logic puzzles. You know, the trick with these is that all the information you need is right there in front of you, just tangled up in words. The real challenge is just untangling it all and putting it in the right order.
Okay, take a look at this one. We've got 5 students, 5 spots in line, and a handful of clues. Right now, it just feels like a jumbled mess of names and positions, right? So where do you even start trying to sort this thing out?
The key is to break it down. You've got to isolate each piece of information. So we have 2 things that are 100% certain. Bernie is in the first spot and Pierre is in the 5th. Those are our anchors. Then we have a couple of clues about relationships, where Lester is compared to Pierre and where Joel is compared to Edith.
All right, let's build this out step by step. We place our anchors, Bernie at number 1, Pierre at number 5. Easy enough. Now, what about that key clue? Joel was 2 places behind Edith. That means they're a pair with 1 spot between them. Let's try plugging them in. What if we put Edith in the 2nd spot? Well, then Joel would have to be in the 4th spot. And look at that. That leaves only 1 spot open, number 3. And who's left? Lester. Does that fit our last clue? Lester was ahead of Pierre? Yep. 3rd is ahead of 5th. So let's see. Bernie, Edith, Lester, Joel, Pierre. Every single clue works. The person in 2nd place is Edith.
Okay, ready for the next one? This puzzle is designed to confuse you. It just throws a ton of overlapping information at you. Nationality, gender, age. Trying to figure this out in your head is, well, it's just a recipe for a headache. So what's the best tool for this kind of chaos?
A simple table. This little grid brings complete order to the chaos. Just watch. Every clue we have helps us fill in another box. We know there are 8 boys total and 6 of them are Canadian. So, simple math tells us there have to be 2 American boys. The clues also say there are 3 American males. Well, if 2 are boys, then 1 must be an American man. You see? You just keep filling in the cells like a little Sudoku puzzle until the whole picture becomes crystal clear.
And once that table's all filled out, getting the final answer is the easiest part. We just add up the totals. 17 males plus 22 females gives us a grand total of 39 people on that bus. See? A problem that seemed impossibly complicated becomes totally straightforward once you organize it.
All right, next up, we're going to tackle some problems with the tool that, I know, can seem a little intimidating, but it's actually incredibly powerful, and that's algebra. The secret isn't about doing complicated math, it's just about translating words into a new, simpler language.
The classic age problem. These can be so tricky because they make you think about 2 different points in time, right now and the past. All the relationships are right there in the words, but we need a way to make them solid and workable.
This right here, this is the most important step of all. We have to translate the English sentences into the language of math. We just pick one thing we don't know, in this case, Chris's current age, and we call it X. From that single point, every other piece of information can be built. So Carl's current age, that's just X plus 4.
And just like we did before, a table is our best friend for keeping things organized. We'll have one column for age now and another for age 5 years ago. So Chris's age in the past is pretty simple, X minus 5. And Carl's, well, it's just his current age, X plus 4 minus 5, which simplifies down to X minus 1. See? Now all the pieces are laid out perfectly.
And here's the final translation. That sentence, 5 years ago, Carl was twice as old as Chris, becomes this beautiful, clean equation. Carl's age back then, which is X minus 1, equals 2 times Chris's age back then, X minus 5. Just like that, the word problem is now a math problem, and it's ready to solve.
When you do the math and solve for X, you find out that X equals 9. But hang on, we're not done. Always reread the question. It asks for Carl's age. So if Chris is 9, then Carl, who is 4 years older, must be 13. And that's our answer.
Now for our final category, we're going to look at puzzles that require a bit of a mental leap. These aren't always about straight, step-by-step logic. Sometimes they're about finding a hidden rule or just looking at the whole problem in a completely new way.
So take a look at this. The very first thing you have to realize is that the little star symbol does not mean multiply. If it did, 2 times 4 would be 8, not 12. So there's some other hidden rule going on here. Our job is to play detective and figure out exactly what that rule is.
So how do we find the rule? We act like scientists. We come up with a guess, a hypothesis, and then we test it. So what if the rule is multiply the two numbers, then add the second one? Let's check. For 2 and 4, that's 2 times 4, which is 8, plus 4 equals 12. Hey, it works. But a rule has to work for all of them. Let's try the next one. 3 times 5 is 15, plus 5 is 20. But the answer's 16. So nope, that hypothesis is wrong. Back to the drawing board. Okay, what if we try something else? What if we add the numbers first and then multiply by 2? So 2 plus 4 is 6, times 2 is 12. That works. 3 plus 5 is 8, times 2 is 16. That works too. I think we're onto something.
After checking that third example, we can be pretty confident we've cracked the code. The hidden rule is add the two numbers together and then multiply that sum by 2. So now we can finally solve our puzzle. 2 plus 3 is 5, and 5 times 2 is 10. And there's our answer.
All right, here is our last puzzle. This one is all about overlapping groups of people. And it's super easy to get tripped up by the numbers. I mean, if you just add 225 and 355, you get 580, which is way more people than are even in the town. So what's really going on here?
Let's break it down. First things first, let's figure out who we're actually talking about. We have 400 voters total, but 40 of them voted for neither issue. So let's just set them aside for a moment. That leaves us with 360 people who voted for at least one of the issues. Now, let's add up all the yes votes. 225 for the first issue, 355 for the second, that's 580 votes. The reason that number is so high is that anyone who voted for both issues got counted twice in that total. So the difference between our big number, 580, and the actual number of people voting, 360, must be the number of people who got double counted. And that gives us our answer, 220.
So after working our way through all these different puzzles, what have we really learned? Well, it turns out we've actually put together a powerful set of mental tools that you can use on any kind of problem, not just brain teasers.
And here it is, your problem-solving toolkit. First, when you're staring at a total mess of information, your first job is to organize it. Use a list, use a table, whatever works. Second, get good at translating word problems into a simpler language, like math. Third, be a detective. Don't just stare at the problem, start testing ideas and look for that hidden pattern. And finally, always work in small logical steps. Don't try to solve the whole giant thing all at once.
You know, these skills aren't just for puzzles. They're for life. Whether you're trying to plan a budget, figure out why your computer is acting up, or just make sense of a complicated project at work, this toolkit is your best friend. So I'll just leave you with this one question. What's an everyday problem in your life that you're going to look at a little differently now? Thanks so much for joining me.